This question is motivated from Kaggle, where Google will give you a lot of raw data to ask you to help predict the revenue. The major challenge here is from the 80-20 law. In this case, only 2% of the visitors will make transactions and therefore revenue, which will make the data ill-conditioned and make statistics harder. So let's begin. Our data is from Kaggle. After doing expanding and data imputation for missing values, we can also get external data from Google Analytics API. After doing multiple data exploration like browser, time series property, we conclude that we should include features like weekdays and months, but not browser. In the model fitting stage, we fit all the models we have learned. From the most significant features, we fit linear regression, which will result in a loss like 5.2. Also, we do sequential-based model like logistic regression to identify the buyer and linear regression to do prediction for those buyers, but this won't help. Maybe this just increase the variations. Then we also do some regularization-based model like XG boosting, lasso, neural network, which will result in this loss table. You can see neural network is the best model with a loss as 4.6. But that is not enough. Actually, we can get external data which will encode every actions the visitor have. As you can see in the table, when people are willing content, he cannot make transactions. And for those people who are just willing content during the whole visitor process, cannot make transactions. We can use this rule to rule out over 2/3 of people, which will finalize our model with external data. We use random forest here to avoid overfitting, and we got a loss of 3.57, which is significantly better than the best model before as neural network. As for the summary, actually sometimes you can show all the models in some practical questions. And in this 80-20 problems, sequential model, the two-layer regression won't help, but the external data can. Actually, you can always get new data to assist your model. As for the limitation is about the missing features. Sometimes you won't get all the features in the model. So maybe we should try some probabilistics models to just marginalize those we don't know. That's all. Thanks.